Okay, okay, it seems to be working. Hi everyone, Microbehunter here, Oliver here. Welcome again to another microscopy live stream on a Saturday. Again, as every time, a little bit of housekeeping I have to do. I have to check that everything is working, sound and video is okay. Thank you very much for the for this information here. Hello again around the world. Today I thought I'm going to show you a couple of microscope slides again. Not only, okay, but those microscope slides that I'm going to show you, they finally arrived. I was able to order them because of your generous contributions. I ordered again a few microscope slides with spines of sea urchins. So 5 of them, which I would like to share with you visually, and I've not looked at them myself. Okay, so what you see over here, that's not the slide, but actually this is from my stereo microscope here. I'm actually moving it now, and these are spines of sea urchins, which I collected a couple of years ago. Basically picked them out of the sand, and I was very happy that I was also able to find some microscope slides showing those spines. I'm going to show you how they look like, I've got a few other things as well that I would like to share with you. Okay, so again, a little bit of housekeeping right now. If you are new to the channel, welcome. You can ask questions in the chat. I would like to ask, please, if you have any questions that are directly related to what I'm talking about, please say on topic or something like that. And please also definitely indicate that the comment or the question is for me. So please also maybe add Microbehunter or add Oliver. And then later on, after approximately 1 hour, I'm going to, in a batch, I'm going to answer all of those off-topic questions that there might be. Okay, so that's a little bit the how do you say the strategy that we'll be using to kind of keep everything a little bit more organized. Usually during the first couple of minutes, I have to give it a little bit of time because more and more people start to join in. I usually use this time to say hello all around the world. From Germany, from London, from Lebanon, from Greece, from all over the world. Texas, United States, Philippines, Netherlands, Belgium. Okay, very nice. Okay, so and even in Esperanto. Okay, what I would like to do, quickly check again, there's 35 people watching now. Okay, good. What I would like to also tell you, if there is a problem with the live stream, so it has happened already before that all of a sudden it was interrupted due to a power shortage or due to a network problem, then I will try to restart it again, of course, but it might be that the link is different than the link that you're using right now. So I don't even know where to start because I've got so many things that I would like to share with you. So first of all, because we're just looking at those spines of those sea urchins, I'm going to show you a short time-lapse video now. Maybe you've already seen it because a couple of weeks ago I did make a video of those spines in this channel as well. But I've got it, this is a video I made. It's in time-lapse, it's a little bit faster, of a sea urchin. Yeah, I picked it out of the water, I put it on the side, when you speed up the video, like I did over here, you can actually see that those spines are actually moving, and they are able to walk as well, so it's kind of searching for water. I have to move away here a little bit, and it's going into the water. Yeah, I think it's a pretty cool looking and also creepy looking little animal. Belongs to the Echinodermata. I talked about those already in one of my previous live streams. And however, right now the slides arrived, which I was able to order because of your contributions. So I would like to, simply show them to you as well. I've not seen them myself yet, so I'll be unpacking them and we'll have a quick look at them. And and afterwards I'll show you a few other things. Okay, so that's a little bit if it's okay with you, that's a little bit the thing I want to do. So I'm going to switch over to the desk view. If there is time. Over here, this is a second preparation of some diatoms that I made. For those of you who were also able to visit watch last week's live stream, I tried it again. Yeah, semi-successful. If it's kind of a backup, if there's some time left, I would like to show this to you here as well. So these are basically not these here, okay? These here are basically 5 antique microscope slides. I think they might be again around over 100 years old. And how do you know that? Because the manufacturer is actually written on here. Yeah, W. Watson and Sons. And the thing that I am a little bit, how do you say, frustrated is that I could not figure out how in the world they made those slides. I tried to research this, but these are cross sections of the spines of sea urchins. For those of you who are regular viewers, you might remember this first sea urchin spine. I'm going to show this to you here. It looks very nice. And this was kind of a little bit the motivator for me to also buy the others. And I'm just going to put this here under the microscope first. I have to take out the other thing here. Okay. And yeah, let's put this one in here. This was actually another slide I wanted to show you. So let's put this one in here. And if you want to know how it looks like, yeah, you can of course also see the stage up there. And because those sea urchin spines are surprisingly nice to look at. Yeah, so I have to go down a little bit with the. Here we go. The arrow is kind of disturbing, so let's turn this off. Let's put this into the. And this is how a spine looks like in cross section. Okay, so I think really nice, really nice. I have no idea how in the world the manufacturer of the slides were actually able to make those, because the spines are very brittle and very hard, so you cannot cut them. So I guess they used some kind of polish it, maybe, just like it's possible to polish some rock samples. Yeah, for polarized light microscopy, you can actually, very hard rocks can also be polished and made thin this way. But I have no idea how they have done that. Yeah. So that is essentially one of the things that if you have any information how this could have been done, then please do share it. I was not able to find any information online. Does not mean that there is no information online, but I'm kind of concerned maybe that this could have been maybe also a little bit maybe of a trade secret by the slide manufacturer. Speculation from my side. In any case, this sea urchin spine you've already seen, and I would like to simply show you now how this looks actually under the stereo microscope. So I'm going to sort of for orientation a little bit. So yeah, so basically what I have done here is let's put those spines away. This is actually a nice one here because this one is actually quite complete. Let's put this away, and I'm going to show you. I've put one of those spines in here into a piece of cork. Yeah, it's difficult to see now. It's a little bit out of focus. Let me focus this. So I'm going to disappear a little bit out of the picture. I hope you don't mind. And I'm going to try to focus this. Okay. Yeah, so this is basically how it's. I put it into some cork so that you can see it. And what I'm going to do now is I'm going to actually put it vertically like this. Okay. And let's zoom in. Let's zoom in. And that's basically how it looks like, yeah, edge on. Okay, maybe we can give it a little bit more. And I have to focus again. Yeah. So this is how it looks like under the stereo microscope. Okay. So we can already, yeah, that's the maximum that I can go now. Yeah, you see that it does, yeah, you can already see this radial pattern. The idea would now somehow be, I don't know, is there a possibility somehow maybe to cut a slice kind of and then put it on stick it on a microscope slide and then kind of polish it down somehow so that it's thin enough so that it looks like this here, right? Because this is a really nice picture, and you could hang it up on the wall, right? I don't know how they've done that. Okay, so they must have used either some mounting medium or some glue, maybe to glue the spine on the microscope slide, and then they must have kind of used some polishing material or some, I don't know, to kind of grind it down. So this is something that I would like to figure out, and yeah, because this would be actually quite nice. So, but this is a slide that you have already seen. So what we do now is we're going to start unpacking. We're going to start unpacking those slides here, and we're going to put them under the microscope one by one. Okay. So every now and then I'm going to have a look at the comments. Okay, and I'll be trying to answer those that are basically topic related, and then the others I'm going to try to answer later. Okay. Yes, so there's a comment from Paul. These slices are probably made in the same way as they make mineral and rock slices. Yep, that's what I also thought. However, the rock slices are kind of much larger. So I guess they must have embedded those spines somehow in some kind of a mounting medium. I was actually even thinking about epoxy, maybe using epoxy resin, a modern material, kind of to embed it and then kind of to polish it down. That might be also a possibility. I don't have any experience with this. So if there's any one of you who knows a little bit about polishing rocks or so, maybe we can, you can share some experience here. Yeah. So it's a question about fluorescence staining. Is another off topic with glycerin jelly. Yeah. And specimens containing chlorophyll. Okay, I'll answer those later on. Yeah. So I'm now really eager. Just for your information, when I ordered them, they came very well packaged. Each slide in a separate plastic bag here. Then the whole thing was wrapped in bubble wrap several times, and then also came in a very large cardboard box, so that essentially nothing is damaged during transport. And and when I touch those slides, I always touch them on the side here. Because of my age, I'm already a little bit difficult of seeing at close distance, and I misplaced my glasses. So what I have to do is I have to hold it up here into the camera. I have to refocus the camera. Yeah, and this is basically echinus. That is a short word of it comes from echinodermata. Echinodermata, like the starfish and the sea urchins, belong to this phylum of animals. Here, this is the company, W. Watson and Sons. If you research the company, it's been around in the 19th century. And over here, section of spine of echinus. Okay, and what do we see over here is we actually see two tiny circles in here. So there seem to be two cross sections on the slide. Yeah, and I'll put it under the microscope now. It's for me, it's also the first time that I'm seeing this, okay? I like to improvise this live stream a little bit. And for this reason, I also would, why not? Yeah. So let's have a look. I mean, of course, I've seen the picture. I've seen the pictures, on the website. Yeah, but I did not look at them very closely. I just said, I'm just gonna have now. I want to make a collection of sea urchin spines. Then we're gonna see how nice or not so nice they look. So there should be two of them. Here's the first one. It seems to be the smaller one. Let's focus. Yeah, I think it's also pretty nice. It's quite complete. By the way, I'm using another 10 times the magnifying objective. Okay, let's go up here. Let's turn up the light here. Looks decent. Yeah, you see, this is actually quite nice. I mean, it's made it's made of lots of calcium carbonate, and you can actually see how thin it is. So that essentially you see the different. You can actually see it's so thin that you can parts of it are transparent. Yeah, it's quite nice. Okay, so that is seems to be the smaller one of the two. Let's have a look at the other one over here. Oh wow. Let's make it smaller again to give a complete view. Down with the light. This looks also very nice. Hey folks, I mean, look, these are 19th century slides. Can you believe this? We're talking about really high quality. So, okay, you might see that look, did you see this? This might be because of the polarized light that I'm using. Do you see those colors here? It's a little bit blue, yellow. maybe that's because of the polarized polar. So I'm going to remove the polarization now. This is now regular bright field. Yeah. Of course, less colors now because, but that's the more natural way of how it looks like. Yeah. Where did you buy these slides? eBay. Okay. So that is the thing. There's another comment over here. You can soften the spines. I also thought about that. Those spines are made of calcium carbonate, and by adding a little bit of weak acid, you might be able to soften it. But I was kind of worried about doing that because I was kind of worried maybe of completely dissolving the calcium carbonate away. This was kind of my worry, so I didn't try that. Yeah. So that is, that's the thing. And Marcel is asking, could you just not try to make a thin slide of the sea urchin spine using a microtome? And the answer would be probably not. And the reason is a microtome is a device which allows you to make very thin cross sections, right? Cross sections. But the problem with those spines is that they're very hard and brittle. So essentially, you might basically just break them, yeah, as you try to cut them, yeah. So that's a little bit the worry. And then now I thought, well, maybe you can soften it a little bit by adding a little bit of acid, because acid kind of attacks calcium carbonate. But then I was kind of worried if you start mixing the whole thing with acid, that you're starting to dissolve all of those delicate structures in here. Right? So it doesn't just soften it, but actually dissolves them and it converts them to carbon dioxide. And that's also something I don't want to do. But again, maybe I just have to try it, right? Those sea urchin spines are actually quite common. I mean, I got those spines that you've seen before. Those spines here. I got them from Croatia when I was on holiday there some time ago. So yeah, they're quite and some folks eat those sea urchins, so there are lots of these spines available. That's not really the problem, but I think that the preparation might be a challenge. Yeah. So are these two slices from the same spine but at a different level? I don't know. It doesn't say so. But I would suppose. Yeah, I would suppose, and the reason being, and you know what, I'm just going to take it out again, because the reason why I think it is it could be from the same organism, is because an indicator, it actually tells you the name of the organism here, right? So it would kind of make sense that if this is that's the binomial name of the sea urchin, then of course it makes sense that it's from the same species. I don't know if it's from the same spine, yeah. But I don't know. Or it could be that the manufacturers, I mean, this was a company, right? Could be maybe that they had I don't know, maybe thicker spines and thinner spines from the same species, and they just always took a thick one and a thin one. Yeah? How in the world did they do that? I have absolutely no idea. I mean, they must have somehow glued it on the slide and then kind of polished it down somehow. But I have no idea how they have done that. So that's the first one. Okay, let's move on to another one. So I'm going to put this into my box, into my slide box, yeah, because I consider those slides a little bit valuable. No, not valuable in the sense that they're very costly necessarily. I mean, they were a little bit costly, but because I think they have some kind of a history attached to them. I mean, this is somebody who made a comment in one of my videos, beneath one of my videos, is that those slides, you kind of really feel that the person or the persons or the company who's made them, actually, they kind of liked microscopy. They liked, because the quality is so good, Again, there are two of them here, okay? There seems to be a different species here. Okay, so again, there are two little tiny dots here that you see. Okay, so let's put this under the microscope, and let's have a look at those. So let's remove the arrow. I have to find here we go. You see, it's a little bit blurry. Just have to refocus this. I mean, look, this is just This is just marvelous, I think. Yeah. I mean, I don't know. It's yeah. This is yeah. Yeah, this is really, really nice. Where's the other one? I have to find it. I thought there were two of them. Ah, here's the other one. Yeah, I really wonder. I mean, that's an interesting thing. I'm not a zoologist here, but is it possible to somehow identify the sea urchins based on the patterns of the spine? I don't know. And look at this here again, something that you keep on seeing in nature. And again, here I have to speculate, but you see that there's this radial pattern over here. Yeah. Yeah, it's almost like tree rings. It could be, again, this is a pure speculation from my side that maybe as it grows, new layers are deposited on the outside. Yeah, and look at this here. Do you see it that over here? A new layer seems to be forming almost over here, right? Yeah, no, I don't know. Yeah, in any case, it is, yeah, it's quite nice. Yeah. So again, I'll look over here. Is a fresh spine softer? Probably not, because probably not. I mean, it's made of calcium carbonate, right? And when you step on a sea urchin, I mean, this is yeah, not so nice. So I guess probably not. Huh? But again, yeah. Sea urchins, I mean, if you just look at those spines, I mean, they're very, very hard and brittle, right? Because they have to basically kind of, I guess they use this also as a form of protection, maybe. So, yeah. The spines are able to move on the sea urchin, as you've seen, but yeah, but the spines themselves seem to be quite hard and brittle. Yeah. So this is I'm occasionally again reading a little bit here. Yeah. I also wondered how these spines are microtomed. Yes, and I think, again, as I mentioned, I do not think that they are microtomed. I think they must be somehow polished or ground down using some kind of an abrasive, because otherwise, yeah. But on the other hand, this is so extremely regular. I mean, this is, I don't know how they've done that. Really, I mean, this is, if we're able to figure this out somehow. But again, people are doing this when they're observing rock samples. For polarized light microscopy, you're also really polishing them down. But the thing is that the rock samples generally can be a little bit larger, right? But they are really, really thin. Huh? So this was number 2. So we've got a few more here to look at. And you know what I promised myself to tell you, and I'm almost a little bit afraid of actually saying it, because it means more work for me. But as a thank you, I'm planning to actually take high-resolution images of those pictures and then make them available for download for you. Okay, because I think it would be a pity if these beautiful patterns of nature were not available, for the wider public. Okay, so what I'm going to do is I started to do this already today a little bit. I'm going to try to stitch the images together, and then I'll put them online and I'll send you a link. It might still take a few days, okay, because I do also have to do then a little bit of image cleanup. I have to remove the dust and increase the contrast and so on. Yeah, so that it's actually quite, and then you can, I don't know, print it out and hang it up on your wall. And so that's the next one here. Here it is. Oh, this is a huge one. Wow. Let's go up with the light a little bit. Okay, so this is now in bright field. Okay, so no polarized or DIC. Isn't this? This is a huge one. Isn't this nice? Yeah, I mean, let's go up. So that's this is now the 20 times objective. Yeah, here we see that it's actually a little bit thicker. You can actually see now that there seems to be some kind of a I don't know, crisscross type of make. It's almost like a sponge like structure here. which in nature you find quite often also in our bone, for example. The outside is very hard. It's compact bone. On the inside, it's very spongy because there are also blood vessels there, there are living cells there, because bone, for example, is growing. And I think it's analogous to bone. We have a similar thing here. Yeah, you can actually see that there is a spine seems to be a living structure, obviously, where there must be living cells, and I guess that those all of those holes and gaps in the spine of the sea urchin, that they are kind of this is where you probably could also find the cells that are actually making the calcium carbonate for depositing. Yeah. Imagine the creator of these slides falling from the heavens and seeing it as a wall on your phones, on our phones, as a wallpaper on our phones. I have to honest, that's one of the comments here. I actually had to think of something similar. I just said, I don't know, 100 years ago, 150, I don't know when it was made, around the 19th century. The people who made those slides certainly had no idea that 100 years later, a lot of folks are actually going to be seeing this, yeah, on a video screen. Yeah, this is certainly something that they would have never imagined in their wildest dreams. Yeah, very nice. You know what? I'm going to go now down. I'm going to now use the lowest magnification. It's the 4 times. It's way too bright again. Yeah, so that is the lowest. I have to swing out the condenser because. So this is And here we go. It's blurry, blurry, blurry. So I have to refocus. Here we go. Okay. Can we, I don't know, should we add some color? That's because the colors, the rainbow colors are because of, again, of the filter and the prism that I have. You can play around a little bit with those colors when I turn here. Yeah, but you know what? There's no need. There's no need to increase the beauty of this. It's, I think, beautiful enough. Yeah. So, I'm just looking a little bit. Okay, yeah. So this is I've got 2 more slides. I'm just checking them also a little bit the time. Every now and then, half an hour we've got. It's fine. I do want to show you something else then as well. I did not show you the label of this one here. This label is a little different here. Seems to be made by a different manufacturer. See, that's refocus. I see it's having some problems focusing now. Yeah. It's difficult to read here. Section. Yeah, I have to, I don't know, I have a difficulty reading this now, also because the low contrast and, yeah. But look at this cross-section here of this spine. I mean, this is a huge, nasty, must be a huge, nasty-looking spine. I mean, it's a couple of millimeters even, I don't know, 2 millimeters in diameter. Yeah. So, this is scary. Yeah. A little bit, can I just say something? Maybe some of you, just like I am, are also occasionally like to make slides, right? Usually we make temporary slides, but occasionally we will play around a little bit with some mounting medium, and we want to preserve some of the slides. Please put a date on the slides, because you never know. Maybe in 100 years, 150 years, somebody's going to rediscover them, right? Yeah, so that's a pity. I mean, Another thing I just want to mention here, and this is something that I really feel, is that some of the slides are quite thick, especially this one over here, yeah? Is extremely thick. As a matter of fact, it's so thick that I even have problems fitting it into my slide box, in some of my slide boxes, because it's too thick to fit in. And the edges here are soft. They're polished. Yeah. So this is not only from the preparation a high quality slide, but also from the actual slide. That the glass slide is of extremely high quality as well. Yeah? Sometimes I don't know. I'm a little surprised that back in the day they were even able to make slides that were that smooth. Yeah. So it looks it's quite nice. So let's put this away here again, and into my slide box, and let's open the next one here. It's again from the company Watson and Sons. By the way, I've found an article, I think, somewhere on Microscopy UK, It's also on a very popular microscopy website. There's an article, or with all of the slide manufacturers. Yeah, so that's why we are able to kind of determine from what time the slide is. Again, here the name of the species, section, and what it is, and there seem to be again 2 of them on here. Okay, I have to speculate again concerning the mounting medium used. I guess maybe Canada balsam, because that was very popular at that time. Yeah, here, they're much smaller. Look, let's have a look here. So they're much smaller. Here we go. Here we go. Up, I bumped. Yeah, so. Yeah, quite nice, I think. 20 times. Okay. Looks beautiful as well. Yeah, not quite as colorful as the others are, but still. And I've got the last one here. Okay. I'm just checking every now and then again in the comment section. Okay. Here is. So, and this one here is the last one. Desk view again. And this one here. Oh, this has a long name. I need to, just a second, where's the focus? Yeah, this is how it looks like. And there seem to be again two cross sections here. Let's take out the other slide. Here we go. Let's put it carefully into the box. And this one over here. Yeah, so again, a little bit too bright. Interesting. Okay. So do you see those dark areas over here? Okay, those dark areas here, these are most likely air bubbles. So this is basically our places where the mounting medium did not fill it up completely in the air bubbles, and usually because the air bubbles have a very different refractive index, that's why they kind of show up as being much darker. Okay, so that's the case here. And where's the other one? There's right next to it, over here somewhere. Here's the other one. That's a little bit asymmetrical. That's also interesting. Maybe it was cut asymmetrically, I don't know. Let's put the arrow away again. So this is now the 20 times. Can open the condenser a bit. Yeah. This one seems to be also a little bit thinner cut than the other one, than the other ones. So this does appear to be a little bit. There seems to be. I don't know if it's an artifact. I think it could be an artifact from the. Yeah. Here a part is missing. Okay, so this is of course the outside here, and you see that over here on the side parts are missing. So this is maybe the place where too much of the specimen has been removed. Maybe during the polishing phase. Yeah. Still doesn't matter. Yeah, it's looks still quite nice, I think. Yeah. Yeah. So that's basically. Just kind of just wanted to share this with you because they look kind of neat. I think is also a little bit of an unusual specimen because normally when you buy a slide box, modern slide boxes, I've never seen. I've seen all sorts of other tissue in them, but and things, but generally not the cross sections of the spines of sea urchins. Yeah, so one day, can you also spot the different? Okay, a dull blade and a sharp one. Yes, that's also possible. I also tried that once. Okay. So let's remove this here again and put it carefully into the box. into my box, which I have standing next to me. So I have now basically 6 slides. You with the cross sections of sea urchin spines, and yeah, I want to show you. Yeah, I have a problem right now fitting it in here. Okay, here it goes. I just want to also show you briefly. Okay, I just want to show you briefly how it looks like. Yeah, so basically I've got a box with a whole range of yeah, antique microscope slides here and here. This is basically, these are the ones, the sea urchins, yeah, that I put in here. Yeah. So, okay, yeah, and also another thing here, I might actually also talk about those. Back in the day, in the Victorian times, some of the slides were also paper wrapped, like this one over here. Yeah. So I've also tried to do that. So paper wrapping, yeah, is also a possibility, and adds a little bit more stability to the slide as well. They don't break quite as easily when you drop them. But also just wanted to show this to you. Not commonly done these days anymore, but also a possibility. So, okay, we talk about the things that happen, not happen, but things from the sea. So we already looked at the, yeah, at this one over here. So that's basically from under the stereo microscope. And I would like to show you now something else that I pulled out from the sand. And that is this one over here. And I'm going to now continue with the stereo microscope because they're too thick and too large to be mounted on a slide. Look at this. Look, those tiny seashells, yeah, and made of calcium carbonate. And here it would be interesting as well. I mean, they look nice as they are, of course, but it would also be kind of interesting to get them a little bit kind of, I don't know, thin and polished, and then you can actually see the different chambers of those yeah, snails and shells and so on. They are made of calcium carbonate, so same material as the sea urchin spines. So basically polishing them and grinding them down to get a thin cross section would also be quite a big challenge here. The question is now, yeah, how to do that. So this is basically the question I think that some of you have already see is what is this here, right? It looks like almost like a tooth or something. But what I think it is I think it's from a crab or something. You know those how do you call those the pinchers, right? I think that's what it could be. Yeah, I found a few of them, not many, but there is also one over here. Yeah. So I think that this is what it could be. Huh? But yeah, those slightly larger objects, which are too large to be put on a microscope slide, of course, are very good specimens for stereo microscopy. And when you look at them, I mean, here it looks okay, yeah. But actually, if you actually look at them through a stereo microscope and you see the whole thing three-dimensionally, it's actually much more impressive. Yeah? But here again, the question, yeah, how would you actually process this to be observed under the compound microscope? Yeah? So that's a little bit another question that I have. So I've tried to now do the following today, and it's the next thing that I would like to show you. I tried to glue a spine of a sea urchin on a microscope slide. So it looks a little bit very, yeah, I need to explain this a little bit here. What you see is a drop of mounting medium. It acts almost a little bit like a lens because it's a drop of mounting medium, and it tries to actually yeah, glue the spine vertically so that it kind of is glued down. And so I wanted to polish it down, right? But it wouldn't stay vertically, obviously. It would simply, the surface tension of the mounting medium, it's always pulled it horizontally flat. Yeah. So this is a little bit the question that I have is how do you actually fix the spine vertically on a microscope slide well enough so that you're able to grind it down without it breaking off. Yeah? And I already had a problem actually gluing it vertically because it wouldn't stay vertically. You can actually maybe also see that, of course, the bottom part is not completely flat either, right? So this is something that I'm still kind of struggling, yeah, a little bit. Did you separate these from sand? Yes, and maybe later on I'm gonna put a link. A couple of years ago, actually, I visited a beach, and this is when I collected those. And what I did is I took the sand, I put it under my. You don't even need a microscope really, because you can see those spines quite well. But I simply took tweezers and separated them out. That's it. It's really easy actually, and you do not need a microscope because they're fairly large, right? But there's one thing that I just want to show you now. This was now in the stereo microscope, but in the compound microscope here, when you put them under the compound microscope. So then. Again, the mounting medium has not dried yet. Okay. When you go up with the light, then you actually see that actually the spine is a bit transparent as well. I mean, this is a fairly dark one, but you're also able to see this internal structure here as well. So this is, would be a nice specimen to look at if I only knew how to properly prepare it. Yeah. So this is the suggestion, basically clear epoxy. That's actually also something that I've been thinking of, and I know that also on YouTube there are lots of folks who are actually making a little, either furniture, for example, or they're just making other artworks where they're using liquid epoxy resin and to kind of embed the things that they want to preserve, right? And this could be also a possibility here. And then maybe I just make a larger block of epoxy and somehow embed those spines in there, and then kind of simply grind down and polish the epoxy, right? So that would be a possibility. Homework for everyone. Collect spines, not only spines, but that's why I also showed you the seashells. Anything which is kind of harder and brittle, and then somehow finding a way to make it thin enough, right? Because we cannot use a razor blade to cut through them. I will tell you now another thing that I was considering somehow, but I think it might not work. I know that there are some commercial microtomes available that have a vibrating blade. Just a second. So, for example, I mean, this here is a razor blade that I put into a 3D printed holder. I mean, you do not see this now, just over here, right? So here, that's a regular razor blade. It's pretty cheap, and I put it in here. And there are some microtomes that actually have which vibrates very rapidly to make it easier to cut. So maybe they're using some kind of a piezo quartz or something, I don't know. Ultrasound type of, I don't know. Yeah, anyways, vibrating very quickly, and this allows it to cut. Now, I tried to use this knife here to cut through one of those spines that I have here, right? But it's not going to work. It's so brittle that it actually tends to break. So if I try to cut it, it will leave a scratch, of course, but then it snaps and then it sometimes fractures. So it's not possible for me to make any controlled cross sections here. And if it's too large, like like this one over here, right? Then it simply falls over and is completely flat. Yeah. So I somehow need a way to get a thin slice. Yeah. So that the slice is actually on the microscope slide. I guess that this is so the blade needs to be toothed. Yes, indeed. That's also something that I would like, a little tiny saw, maybe, but I haven't found one. Yeah. So that's simply something I wanted to share with you. So I talked mostly about sea urchin spines now, but for a couple of minutes I want to show you also a few other nice things, which I have. Not so nice. Let's do the not so nice one first. Okay, something which I kind of found interesting. I mean, not so nice, but I mean, it's more interesting than, again, under the stereo. This is also something that I pulled out of the sand. This is where it's out of focus. Let's go down with the magnification here. And then I did a little research, and I found out that this is indeed also an issue. How many of you know what this is? Yeah. How many of you know what this is? I was actually hoping almost sarcastically hoping to find some microplastics, because then I could have made a video about microplastics in sand on the beach, right? I didn't find any microplastics, not because they're not there, but it could be that kind of because they have a less density, kind of that they're washed away, and then on the sand you kind of settle, more denser particles can be settled, and this is what I found in them. That is glass. These indeed. These are glass chips, and indeed, I read somewhere that glass pollution is also now becoming more and more common. Yeah, so glass bottles and so on. They kind of also break, and there was surprisingly much glass inside a sample of sand. Yeah, something that I did not. Something that I did not expect. So this is simply also something that I wanted to share with you. It could be maybe that some of them look a little bit more like quartz rocks, but I mean especially the green ones and so on, and sometimes they're fairly smooth as well. So it does look like human-made glass as well. So this is interesting. James is mentioning, why not polish one horizontal? That's also something that I was actually thinking about, because the spine which was horizontally, would that be possible to kind of polish it horizontally? Yes, but there is one issue that I just also want to show you. Here in the scope, and that is the following. Because the spine is round, right? It touches the slide on the bottom, just with the bottom part, right? So if I really want to have a nice cross section, I somehow would have to polish the spine horizontally first, so that it's flat, so that I can glue it on a slide, so that I can then polish the top part. Yeah, because it's round on the bottom side. So even if I were to polish it halfway, then it would still be too thick. Yeah. So this is kind of also something that I was actually considering. Yeah. But I'm going to show you a little tool that I bought myself today to kind of share this with you. Okay. So this is the thing that I found as well. Okay. So spines and this, and the sand grains are not so interesting. But I've got some other commercials, another thing that I would like to show you. Where is this? In my chaos, I misplaced it now. There was this one slide. Wait, just a second. Here it is. Okay. And that is the following. This is because we talk about marine water and so on. Look, let's try this here first. And I'm going to explain to you what this is. I might have to. Yeah, it's unfortunately a pity that the part that I wanted to show you is probably not visible anymore, because it's okay. Am I happy? I already wanted to tell you this sample is completely dead. This is what I wanted to tell you. Okay, we see some movement. I will explain. I was actually, I already prepared to say, this sample is already dead. It's not. Okay, let's do the following. Okay, I will explain. These seem to be almost, I don't know, maybe they're tiny diatoms. Okay, you know what? Let's go up 60 times. Let's enjoy them for a second. Because, where do I have them from? Because back in 2022, over 2 years ago, I visited northern Germany and I took along a marine water sample with a little bit of sand. Here it is. Okay? It survived, evidently. Okay, then not as much as right at the beginning. I'm going to show you a time-lapse video. Okay, but these little diatoms here, look, they seem to have survived. I want to show you now how this actually looked like right at the beginning. I made a video of the sand grains, because there are lots of sand grains. Look, I'll just show this to you. It's mostly sand grains what we have here. Yeah, it's blurry. Look, they're all the same. So this basically means that we seem to have a dominant species, or dominant, assuming it's all the same species, a dominant organism here that was evidently able to survive for the time. But what you see in the background are all sand grains. Okay, and when I shortly after I collected this sample, basically there was way more movement going on, and I made a time-lapse video which I would like to show you. I think it was this one. No, that's the sea urchin from before. Yeah, this is the time-lapse video which I made right after I collected the sample, and look how much movement there is. Right, many diatoms are kind of pulling along on the sand grains. So yeah, it was very alive, and I thought that actually in the meantime that the sample is not alive anymore. But as we've just seen, yeah, some of them seem to have survived. Yeah? So this is actually also something that I want to mention. If you collect water samples, and this is something that I have done over here, it is always make sure that, and I kept the lid on the whole time, but make sure that there is always enough air in here so that the whole thing does not become anaerobic. And I kept the lid on here to prevent evaporation of water, because if water evaporates, then of course the salt concentration goes up. That's something, and then yeah, the organisms might have indeed have a problem. Yeah, but evidently some water samples can be stored for a fairly long time, and then what you see is a kind of a progression of life, and different species start to become dominant over others. Yeah? The question is here: what kind of diatoms are these? I tell you, I'm not a diatom expert, but you have to consult an identification book. But then you got to also be a little bit careful. You see, you can identify, of course, diatoms, but it's always a question, like with other microorganisms, to what degree and to what level. So we're back now to the slide. Okay. So there are so many different types around. Yeah. That yeah. Just by looking at them, you might not be able to identify them, or you might be able to narrow it down a little bit, but not be able to identify it all the way to the species level. Yeah? That's also a nice one. Don't call them water sample, call them micro pets with low maintenance. Micro aquarium. Indeed. Yeah, actually, that's what it is. Seriously, I mean, these are yeah. That's a low maintenance, indeed low maintenance, because all you need is a jar of water. And yeah, I over 20 years ago, I used to have an aquarium with fish, really nice in the living room. But that is indeed a little bit of work, because you have to exchange the water, of course. You have to pull out the dead fish occasionally that start to appear. Yeah, and sometimes the fish gets sucked up into the aquarium pump. Then feeding is very delicate. If you overfeed, then you have an algae population exploding. Yeah? But this actually, I have to tell you, this actually makes me a little bit happy. Not happy, it's the wrong word. Positively surprised that indeed there are those that have survived for over 2 years, almost 3. Yeah. So. Yeah, so very nice. Yeah, next thing I wanted to show you. Yeah, I'm again basically my son's going to give me later on in a couple of minutes again the questions. But I do have 2 more slides. These are commercial slides, and this one are called foraminifera. These are basically also single-celled organisms that have a shell made of calcium carbonate as well. However, don't have too high expectations, because this slide has a slight problem, and I just want to show it to you so that you do not make the same mistake. Let's go down a little bit with the magnification, and here we go, and here, this is where the sand grains start, and those forams are basically, you also look like sometimes like microscopic snails and so on. So this one could be one of them. Yeah, this one over here maybe. Yeah, there are not so many here in the sand grains, but yeah, if you look around, then you might be able to find a few of them. I did not find so many here. But the reason why, I don't know, maybe this one up here, but the reason why I wanted to show you this slide is actually because it illustrates a small, how do you say, preparation problem. Again, I'm going to remove now the thing here. It's a little more colorful. You know what this? Yeah, let's go bright field and maybe a lower magnification here. And the problem is that all of the sand grains accumulated now on the side. Now we'll show this. Yeah, see there are lots of them here. Okay. This round thing that you see here on the top, that is the edge of the cover glass. Ah, look, this might be a foraminifera over here. Okay, we can maybe go zoom in a little bit more. And this is always the problem when you basically immediately put the slide vertically before the mounting medium has dried. This could be one. Yeah, you can actually see that there's a little a shell-like structure. Yeah, and in it you have a cell living. And extending its so-called pseudopodia, which are the false feet. Yeah. This one might be one as well, because you see those tiny little spikes here on the surface. Yeah. So basically, there are certain sand samples that have that. But when you look at this slide here, not under the microscope, but actually in on here, okay, and you can actually see that the sand with the forms is all located down here. Why is that? The reason is that the slide basically was mounted, and too soon they put it into a slide box, and when this happens, then of course when the mounting medium is still liquid, the particles sink down and then they start to accumulate on the bottom side. So basically, just a reminder that when you actually mount your whatever you mount, just make sure that you store it sufficiently long, horizontally. Sometimes if you look at it under the microscope, and if you take a tool like I don't know, some tweezers, and when you apply a little bit of pressure on here, then you might actually still see that there is still some liquid moving around, and then you know that it's not completely hard yet. Okay, and so that's basically simply something that I wanted to show you, that if you mount things, that you be careful that this doesn't happen. But actually, on the more nicer side, I found another one called radiolarians. Okay, these are also single-celled, and they also have a shell, and the shell is of silica, but these are not diatoms. Okay, so silica and calcium carbonate seem to be quite common in nature for making shells. So let's have a look here as well. Scope view, and here we have already the first example, and here the door opening. Thank you very much. Here are the questions, which I'll address in a minute or so. And basically, look, they look very nice. And I'm going to show you now how this looks like at 4 times. And I'm going to focus, and they are really nice in dark field as well. Unfortunately, I only have dark field for 4 times. Here we go. Okay. It's not quite large, but yeah, they have a very huge difference in refractive index to the surrounding medium, and therefore they start to shine quite brightly. But let's zoom in a little bit. So if you ever get a chance of getting these like radiolarians, then it's also quite nice. Let's go here, and here we go. Okay, so they have also these complex looking shells. And that's how they look like, and very good also to do some focus stacking. Basically what you do is you kind of take pictures at different levels, and then you can combine it on the computer into one in focus image. So basically, I also wanted to show these to you. Let me quickly again go through some of the questions. We need to make a collection of various jars of various organisms to observe micropets all winter. As a matter of fact, this is something that I'm have been doing as well. That's also one of the reasons why I kind of keep a lot of jars with different water samples, so that if I want to observe something, I always have something to observe. Yeah. Indeed. And if you have an aquarium, then you've got plenty of things in there anyway. I also have a water sample standing for a few months already. Initially, they were ciliates, then today abundance of rotifers. Yes, there's this natural progression of organisms, and usually, or one of the factors that has a very strong impact is the level of oxygen. So different organisms have a different preference for different amount of oxygen, and this can impact greatly the type of organisms that are present. Yeah. I forgot to ask if the more transparent Echnos slides could be shown on the dark field or phase. Oh, I get it. Good point. Thank you. Thank you for the recommendation. This is actually something I wanted to try, but I didn't. I forgot. So thank you for reminding me. The request was, can we not put some of those slides, basically also using different contrasting techniques? So, for example, dark field. I've never tried this, okay? Or phase contrast. So let's do the following here. So let's put this in here. This here is now, yeah, that's the one with the air bubbles. Okay, let's have a look here. Let's focus this. So this here is now in, this here is in DIC. That's why we have some of those colors in here. So that's not really. So this here is in bright field. It's too bright. Go down with the color. So these are not the natural colors. In order to get to dark field, I have to use the low power 4 times objective. Otherwise, I don't get. I have to open this here and I have to put in the dark field, which is the one for phase contrast. Look at this. Look at this. That's dark field. Very nice. Very nice. You know what? Let me try a bigger one. This is actually quite nice. Let me see. There was one which was a little bit bigger. Let me try another one. This was the big one. Nice, nice, nice. Okay, so let's try this one here. Yep. Also good. Focus. Very nice. Okay. Can turn up the brightness a little bit. Yeah, so thank you for reminding me. Looks good in dark field. So what about phase contrast? Phase contrast is, I only have it at 40 times, so the magnification is going to be really high. Okay, but why not try it? Here we go. I have to open this here. I have to give it more light. I have to. Yeah, that's now phase contrast, and I cannot even find the focus. That's the problem that I have. You know what I will do? I will now first maybe just focus it, find the focus. We're using a different objective. So that is now in focus. So maybe I'm able to find it now also in. So that is now, okay, that's now phase contrast. Okay, as you can, very magnified. Okay, but I could imagine that this also might look kind of nice. Okay, let's go turn it up a little bit. So let's so phase contrast, and careful, I'm going to now switch over to bright field. Actually, I think, I don't know. I think actually bright field looks nicer. In this case, well, I don't know. Yeah. In any case, yeah, we can play around with that. But that's again bright field. Yeah, also okay. Yeah. So this is basically something. Yeah. Plenty of things to play around with. Okay, what time is it? Yeah, what I'll do now for a couple of minutes is the following. just some comments here before I go through the questions that I've got here. The white diatoms would make awesome black and white pictures in the bathroom room. Yep. Yeah. Okay. I think Olympus or another brand also have similar contest. Oh, that is the. Could you talk about the Nikon Small World Photography Contest, or it's amazing and we can do some of these pictures with basic instruments? Okay, I have a couple of years ago, as a present, I got a calendar from Nikon. Every year has a contest of beautiful microscope pictures. You can see the pictures. Just Google Nikon, Small World of photomicrography contest. If you Google that, you're going to find it, and you're going to find all of the prizes there, and the prize-winning pictures. However, big however, the pictures are so good. The pictures are so good, and they not only look good, but they're also scientifically interesting, right? That it's difficult to compete. But then again, of course, participation is everything. Yeah, I know, but the pictures really are really good, and you can actually buy a calendar. And I once got a calendar as a present. Maybe, I mean, we're not quite at the end of the year yet, but maybe for 2025 they'll have another calendar. I can imagine. Yeah. So it's really nice pictures. But if you look at them, it's not only they look nice, but also they are really scientifically very original and unique, and it's more than just looking nice. It's just also interesting scientifically. Yeah, what it actually shows. You know what I'm going to do now is I'm going to try my best again to. I'll quickly. I hope I didn't forget anything. Possible dark field. Yes, I just did that. Yes, Kunstformen aus dem Meer. That's a book from Ernst Haeckel, a very well-known person. I know the title, but I don't have the book. Yeah, water samples. So can you adjust your DIC to gray line design? Okay, maybe this was actually it's going to be answered here. What do diatoms eat? Diatoms do photosynthesis. They make their own food to make sure that there is enough carbon dioxide present. How? By always allowing fresh air. Sunlight is important, and of course they're living in water anyway, right? So diatoms, they eat essentially they're nothing. They make their own food. Because they are related to the plants and the algae, and therefore they do photosynthesis and make their own food. Of course, they need nutrients and minerals, otherwise they wouldn't be able to live, but they usually get that out of the water anyway. But the actual energy source is the sunlight. Okay. So that's why if you store them, Another thing is if you store water samples, do not put the water sample into direct sunlight. That's also important. Because what might happen is if there is too much direct sunlight, first of all, not all algae like it. Sure, they need light, but sometimes direct sunlight is too intensive, and then it can also cause an overheating of the water. Okay, and then if the temperature is not right, then other microorganisms might also suffer a little bit. Yeah, so generally speaking, it's good to leave a jar at a bright, but also at a bright place, but not one which is exposed to direct sunlight. I wanted to try staining with carmine. I've tried some staining with carmine as well. Okay, with the chromosomes. Does the carmine have to be 100% pure? Is it usually sold with added sugars in it? I think that the thing is the following. Carmine is also, I guess, because it's also a food coloring, I think. So it could be that sometimes it comes maybe in this kind of a paste that you can directly apply to cakes. And I would not use that. It's got to be fairly concentrated in a powdered form. You can try it out, but generally the more, more additives there are to it, the less controlled it is. And it's already difficult enough to stain. And if you now have basically also other things in it, then it just makes it more difficult to reproduce. What you might try is, if you cannot get pure carmine, I know that sometimes there are so-called Easter egg colors, and those Easter egg colors, not in a liquid, but sometimes come in a powdered form. which you have to mix with water and so on. And I've not tried this myself yet, but usually they are more intensive than if it comes mixed with other additives, which are actually ready to be used, possibly as for decoration purposes of cakes. Yeah, so I'm not recommended, but again, we're doing this as a hobby, so try it out. That's what I would probably suggest. Yeah? But I've used pure carmine powder, and yeah. Should I keep specimens containing chlorophyll in the dark when creating a permanent slide to avoid photosynthesis and oxygen bubbles while the specimen is still alive? Should I keep specimens containing chlorophyll in the dark when creating permanent slides? Let's put it this way. I think the problem might not even appear. I think you're concerned that when you're making a permanent slide, and you're adding the mounting medium, then photosynthesis will cause the formation of oxygen bubbles. I want to say the following. If you, I mean, I get the idea, but probably it's not going to happen. Because if it depends on the mounting medium. Normally what you do is you dry the specimen first. Okay, you dry the specimen first, and then photosynthesis stops anyway, and then you add the mounting medium. If you want to mount, however, I have to kind of qualify myself. If you actually mount algae and other delicate water organisms, then you're probably going to mount it in a medium which does not contain an organic solvent. So for example, I've got a U-Pearl mounting medium here, very bad for mounting organisms containing chlorophyll, because the solvent will actually dissolve the chlorophyll out of the cells and it will basically lose color. But at the same time, bubbles won't form because you're killing off the cell and photosynthesis stops. Right. So what I would suggest is I would suggest using some kind of a water-based mounting medium like a glycerin jelly. I've also played around with Elmer's PVA glue, but generally as soon as you add some kind of a mounting medium, the conditions are not really right anyway for photosynthesis to continue to the extent that you have significant bubble formation, right? So I think that the problem should not appear in most cases, yeah? Because you add the mounting medium, it starts to dry off, water level drops, the plants or the cells stop making photosynthesis, yeah? So I guess it's probably a question of minutes, right? And I think, if I remember correctly, I have not seen oxygen bubble formation such a big issue when making permanent slides. Yeah, I would like to see how a permanent slide is made with glycerin jelly. Difficult. How to prepare the glycerin specimen and how to execute. Is this even possible for hobbyists? Yes, it is possible for hobbyists. I think I once tried it several years ago, but glycerin jelly is one of the most difficult mounting media to use. For several reasons. Let me explain this a little bit. So glycerin jelly is a mounting medium which is used for mounting delicate water organisms, because the glycerin jelly does not completely dry out. It doesn't completely dehydrate. It shouldn't. It stays a little bit semi-solid as well. And you have to mount it like this, that you have to melt a piece of glycerin jelly either on the slide, or you just put the whole bottle into a warm water bath. And if it's too hot, then the jelly breaks, the gelatin breaks, denatures, and it won't become solid anymore. So you're not allowed to heat it up too much, but only about to 45 degrees centigrade, right? If you heat it up too much, the glycerin jelly breaks, so to say, and won't work anymore. And then after you've mounted it, you have to allow it to dry a little bit. It won't dry completely, because the glycerin will actually also attract moisture from the air and will prevent complete dehydration. The glycerin also is important if it's kind of for the refractive index. And then you have to put a ring around the cover glass, like you've seen over here with my the slides from the sea urchins. They all had a ring around it, and the ring in glycerin jelly is important actually, because it actually stabilizes the cover glass, because it's the glycerin jelly is not completely solid, it's semi-solid, and also it prevents exchange of moisture with the surrounding, right? I once tried to make glycerin gelatin. you have to get basically the gelatin, not the one from the kitchen, because they sell it for making cakes and so on. But that is apparently too acidic. So you have to get the gelatin in basically laboratory grade gelatin, which is really pure gelatin, and you have to add some kind of a disinfectant as well. Otherwise, the whole thing is going to become moldy. I've read somewhere that some people have added mouthwash, a couple of drops of mouthwash, Listerine mouthwash, to basically for preventing it from becoming moldy. And then when you melt the glycerin jelly, you also have to put it on a warm slide. So you need some kind of a warm plate so that it doesn't immediately turn hard again. And then apparently it's really difficult because it makes a lot of bubbles. Yeah. So interesting. Okay. But to my knowledge, one of them, and from my experience, one of the most difficult, yeah, and you need a vacuum chamber as well, because when you prepare the glycerin, you have to make sure that there are no gases in there, otherwise you have a lot of bubbles forming. Okay, I went into really lot of detail here, yeah. Oliver and other folks, does someone know a good resource for fluorescent staining protocols, tutorials, and manuals? Off the top of my head, laboratory manuals. Fluorescent staining is honestly this is pretty advanced stuff. Okay, normally what you do in fluorescent staining is you use some kind of fluorescent antibodies. I mean, this is laboratory stuff and not so cheap. So I would say that what you might try. I think I once tried that. But I wasn't very successful. What you can try to do is there are these fluorescent yellow markers for highlighters. The highlighters they're called, right? For highlighting text. And the yellow one actually will start to glow when you add blue light, right, or UV light. And actually, I think you can actually. I played around many years ago, and I tried to stain something with the ink. It's not ink. How do you call this? Yeah, the ink of those yellow highlighters. And I think I got some parts to actually show up under blue light. I did not use UV light, but actually blue light, and it was kind of a proof of concept, but it was not really serious, anything serious, right? But you're looking for real resources, and here I just that's basically all. These are standardized protocols that are used. You just have to research them. Very often in scientific publications, they mention these things. Yeah. But I think what I would say, probably there is not one single method, but really it depends a lot probably on the actual things that you want to make visible. Yeah. So I know I've once worked at the university a long time ago with fluorescent microscopy, and these slices are probably made the same way as they made mineral and rock slices. Yes. Okay. Could you just not try to make it a thin slide in? Using a microtome. Yes, I also mentioned this. The problem with a microtome is that the microtome knife probably would not cut it properly, but would probably kind of chip off or shave off the top layer and not make a proper cut, because it's simply too brittle, the spine. Yeah, so that's a little bit the problem here. Recommendations for mounting media for diatoms. What was this? What is it called? Depex or something? There are some. Everything suggested online seems prohibitively expensive. Yes, because basically because they are made for laboratory use. Toxic, yes, because they contain solvents, very often xylene. Yeah, or discontinued, yes, because the market was too small. Okay. So that is indeed something that I can basically say it's difficult. However, thank you for reminding me, because I did prepare something else as well, which I have to show you, because it actually relates directly. It relates directly to your question about mounting medium. Okay, let me quickly put those back again into the box. What I've got here is the following. And I'm going to put this under the microscope, okay? I've got here so-called diatomaceous earth using two different types of mounting medium. So that actually relates directly to your question here. So I have to go up with a magnification. So we find the focus. So this is some commercial diatomaceous earth that I bought. The question is where is the concentration high enough? Here we go. So it doesn't look like anything yet because the diatoms are too small. Here we go. So let's go 40 times. Okay, so this here is diatomaceous earth, which I bought over Amazon, and I mounted this one over here, the left one, right? I mounted in Elmer's PVA. What else, right? You already know it because I've been talking about it. I don't know. Yeah. So this is basically Elmer's PVA glue, which is water-based glue and which works reasonably well for most cases. Okay. Forget about the refractive index. I have no idea. Okay, but at least you see that we are able to see something, right? And these tiny things, these are indeed, of course, that. Let's 60 times. Okay, let's open it a little bit. Let's change this over to the correct filter. Open it a little bit to make it brighter. Okay, so these are basically fossilized marine diatoms. Let's now move over, and the other one is Upearl, which is actually, it's not quite as toxic as those that contain xylene. And this is also a general purpose one, which is commonly used by folks who are actually mounting insects. Yeah? And I like to use it because it does not contain those totally nasty solvents. And here, this is now the one using Upearl. And I think you do see a slight difference. I think that over here, basically the diatoms are a little bit better visible, right? You know what? I'm going to completely remove the. So this is basically now in bright field. Okay. Maybe there's some places where the concentration is a little bit higher. Here maybe. And let's move over again, and that is the one here with. That's the one with the PVA. So what I think is because in the PVA it looks a little bit more transparent. Yeah. So I think that the refractive index is maybe too similar here. However, the refractive index will change as soon as the water or the solvent evaporates. But I think this already shows you that indeed the mounting medium can make a difference in the way that the specimen actually looks like. Okay. So this is PVA glue, and over here, that is Upearl, and you just see it better. Yeah, you see that the contrast is higher. Yeah? So just wanted to kind of show it to you because the question kind of related to that. Okay, so I'll quickly do the following. I'm not going to stress myself. I'm just going to continue to answer those questions, and then later on I'm going to try to address those questions that might be still in the chat. Okay, so that was basically the refractive index one. Okay. Off topic, when making a culture of paramecium or ciliates or whatever, does it need to be a crushed wheat grain? Because you are saying it countless times. The crushed wheat grain is a very common one, which basically kind of proved to work well. However, there are other possibilities as well. What you can do is, so the crushed wheat grain has the following advantages, and that's why I like to use it a lot. You crush a wheat grain because the wheat grain contains this seed coat around it, yeah, and you crush it, and this kind of exposes the starch on the inside. You put it into water. Bacteria will feed on the wheat grain, and the paramecium and other ciliates will feed on the bacteria. And what you can then do is that the wheat grain will become kind of slimy. But you're still able to take tweezers and take out the whole thing. So that means you have, in a very small area around the wheat grain, because it's kind of slimy and so on, you have a lot of paramecia. So the handling is easier. You can also try to make a so-called a milk culture, which is also documented for growing paramecia. And what you do is you add a very small amount of milk, into your water sample. I'm talking here not even, I don't know, maybe not even a full drop, maybe just something that goes between your tweezers here. So just that the water sample, the jar, becomes slightly cloudy. And then you wait for several days until the cloudiness disappears. The cloudiness is due to the fat droplets and the milk proteins and so on that are basically now suspended, and this serves as a food. The problem with the milk culture, why I found it difficult, is because if you add too much of this, then the bacterial population explodes so quickly that essentially it starts to turn foul very quickly. Okay, so overfeeding is easily possible, but while with a crushed wheat grain, you basically have a concentrated area where you have the paramecia forming. Yeah, so it's yeah. So this crushed wheat grain is not something that I invented, but actually is kind of yeah. I've also got it from a book. I tried it, and then I basically found it to be reasonably well working. I tried it with rice, didn't work so well because rice does not have the seed coat anymore and kind of fell apart as soon as you try to pick it up. Yeah, I even tried that because what's a crushed wheat grain? It's kind of those oats, for the breakfast oats. Yeah, that's basically the same thing. Yeah. What kind of diatoms? Yeah, again, that's diatom identification. You need an identification book or be a little bit of an expert, which I am not, I have to admit. If I want to find out which organism it is, which microorganism it is, then I simply do the following. I consult an identification book, or I try to search a little bit online. Once I've got a name, then if you type in the name, then you can actually find more pictures online, and then you can actually cross-reference using those photographs. Yeah. These are saltwater diatoms. Well, if this refers to the one that I have over here, yes. And a little bit of a pity because in the sample that I showed you, where we actually surprisingly found those tiny diatoms moving around, there was actually a diatom shell of a round one, because there are those nice round diatoms as well, and they're mostly marine, in salt water. Yeah. So, what do diatoms eat? Yeah, they do photosynthesis. Yeah. I would like to know where and if in the USA one can get the mounting medium used for mounting bugs. So basically, if you want to mount insects, I mean, you can, of course, you can mount it with Elmer's PVA glue, right? Diluted with water. I mentioned this already many times. However, U-Pearl mounting medium, this one does have that's the standard mounting medium that entomologists use, basically insect folks. And the reason why this one is so popular for that is because it has this clearing. How do you call this? Clearing activity. That's correct. Because very often the insects have a very dark exoskeleton, a dark brown exoskeleton, which is doesn't allow light to go through, and you have to bleach it, right? But in many cases, it's simply enough to directly mount it. You basically put the insect into alcohol to remove all of the water. You remove the excess alcohol, and you can directly transfer it into your pearl, so you do not need any nasty toxic solvents like xylene and so on. You just take it from the alcohol, you remove all of the excess water, and you can directly then mount it in U-Pearl, and U-Pearl is able to handle it. Yeah. So this is the reason why it's fairly easy to use. Disadvantage of U-Pearl is it takes a very long time to dry. So you have maybe a month or 2 months, even 6 weeks, simply depending on the amount of U-Pearl that you have to store the slide horizontally to completely dry. Okay, so this is I got this actually from a supplies shop was selling things to basically people who are collecting insects as a hobby. Yeah, and you can buy it still over laboratory shops because in the universities and so on they use this, of course, but it's always a problem because they might not always sell to private people, right? And luckily I found this one shop that basically had it. Yeah. But if you don't have that, and if you're starting out and you just want to start this as a hobby, then please do the first just for practice purposes. This is perfectly fine. Yeah, it's clear. They have it's completely the clear one. Yeah, not the white one. Yeah? You know what I suggest? Yeah, in the United States, try to search for or contact Carolina Biologicals. It's called. It's a school supplies company. Carolina Biological, I think it's called, the company. Maybe there are others as well, but but I know that this is a pretty large school supplies company, and they might be able, if they don't have it online, maybe they can actually, yeah, they have the connections maybe. Carolina, I think it's called Carolina Biological or Biologicals. Yeah. So off topic, can you adjust your DIC to gray line, the size DIC, or is the Olympus always blue background? Oh, this is a technical question. No, it is not always blue background. I adjusted it to blue. So I'm just going to show you. I mean, I cannot show you really because there's no camera there. But yeah, this is a fairly technical question now, okay? The background is blue. I have a wheel, a little thing to turn here where I can change the background color. But there's also something on the bottom of the microscope which I can turn. And then basically I can also make it appear gray. Okay, like now, yeah? And yeah, so, and when I turn it on the top now, I don't get blue anymore. Yeah, so I have something to adjust, but I usually keep it so that the background is blue. Why? Because it kind of emulates, gives you the idea of water, kind of a little bit, you know. Yeah, that's the only reason. It's blue is also one of a color I like, and that's kind of the reason. But yeah, you're actually absolutely correct. That I can not only adjust it on the top, but I also have a little adjustment wheel on the bottom, and then I can also basically change it to other colors. Yeah. Forgot to ask you if the more transparent Echinus slides could be. Yes, I did that before. Okay, so what I'm going to do now is after 1 hour and 30 minutes, I'm still going to look at some of the comments or questions. Yes, it's confirmed. Carolina Biological Supply. Michelle, thank you very much. Okay. Usually I'm not, because I'm living in Europe, I usually do not order from the United States because of the time it takes, and also the import tax issue, and sending chemicals is anyway a difficult thing these days. Yeah, so that's the reason why. I try to find locally. What you can also try, a company that I can recommend is, and I don't know if they have UPearl, but they might have other mounting media, is Brunel Microscopes in the UK. It's called Brunel Microscopes. You find them online as well, and they have a lot of stuff. And service is good. You've got folks there who you can email to, and absolutely no issue. Okay, so I bought a few things already directly from them, and I can just say I'm not sponsored by them or anything. Okay, I just say that I've had so far, with a few times that I've ordered, I've had a good experience with them. Yeah. Brunel doesn't work from Canada, unfortunately. I've just seen here. That's a pity. Okay. Yeah, didn't know that. Yeah. Let me quickly check here. More biology than microscopy, but it would be nice if you made a video on the differences between marine organisms versus freshwater. I don't understand how they survive in salt. Oh, that is something I can definitely explain. That's simply a question of osmotic balance. Short question from your side: how can organisms survive in salt water? I give you an extreme example in the Dead Sea, which is fully saturated with salt, right? Maximum salt concentration in the Dead Sea. They found bacteria there. I think one of them is called Haloarcula. And how in the world are they able to survive in 100% salt concentration? Why by osmosis shouldn't they be losing water to the outside? Shouldn't they? Yeah. And as a matter of fact, scientists found out that even though the salt concentration is so high, water is moving into the cell. How is this possible? Yeah, it defies apparently logics, right? And the reason is because those cells will actually pump salt ions into the cell actively, so that water is able to flow in. So basically, the inside of the cell is saltier than the outside, which causes water to flow in by osmosis. Okay, this was a very short explanation, right? Short answer: it's a question of water balance. And as a matter of fact, I've prepared some video clips about paramecia, how they are actually pumping water out of the cell, because paramecia in fresh water, they have a problem that the inside of the cell has a higher solute concentration. Water is always moving in. So maybe the cell is going to explode and pop because of too much water. And in order to prevent that, they have a so-called contractile vacuole, which pumps the water out again. Yeah. So the thing is your question was, how can they survive in salt? This is indeed a challenge, but the opposite is also a challenge. How can they survive in fresh water, right? Because then you've got water moving into the cell, which is also a problem, right? So you see that in both cases, cells have to have a mechanism in place to deal with water balance. It's a central concept in biology, so thank you for the question. And as a matter of fact, you might know that I'm actually a teacher in a high school. And this is actually a huge chapter. The whole thing about water balance and osmosis is a huge thing. Yeah, it's a central process in biology. Yeah? For me, I've put a few grains of flour in a large micropet jar, and 3 days later there was a visible layer of bacteria, a gray veil. It's crazy how little they need. Yeah, be careful with the bacteria. They will decrease the oxygen concentration in the jar very quickly. Yeah, so that is, and then if their oxygen level drops too much, then also other microorganisms like the ciliates and so on are not able to grow, unless there are some photosynthesizing plants in the jar which actually produce again oxygen. Yeah? So it's all a very delicate thing. You know, as soon as you start twisting around and trying one thing, then there's sometimes side effects happening. Yeah? Daniel said the following: I already played with the markers. They're good to check if it works. Okay. Yeah. So I'm referring to those highlighters, the yellow highlighters, which also have a fluorescent dye. Yeah. So very quickly, and then I'm going to call it quits for today. Yep. Rhodamine again. Alexandra is saying something about a comment here. I'm going upward, up from the bottom. I'm going up the comments here. Okay, so okay. So apparently there seems to be the interest making some slides using glycerin jelly. You know what? Thank you for the recommendation. I'll pick up on that. Yeah. Okay. Have you tried UV glue as a mounting medium? Yes. This is an interesting one. Thank you also for the question. Bob asked the following about what about glue or nail polish that actually cures when you add ultraviolet light. I tried nail polish. It's not a real nail. It was kind of like a cover that you put on a nail, but it was too thick. It was too viscous. Okay, so that's the problem that I had with it. I paid quite a bit of, I think 15 euros once for this UV curing nail polish, but it was actually, I could not use it as a mounting medium because it was more like a gel than as a liquid, but maybe there are even liquids out there as well. Yeah. Okay, so this was a question. The question here is, did you already find people to get a special episode with other amateur microscopists at the same time? Not yet. Still trying to sort out the technology here. So the idea is, but I can announce this now, the idea is if we kind of figure out the technologies, maybe several of us can go online at the same time. So if you have a YouTube channel, many people already have one. If you have a Gmail account, if you are able to figure out how to actually make a live stream, then what I could do is I could actually collect several live streams together and then basically send it out over this live stream here. So it is possible for me to actually combine several windows into one window so that people can actually see several things at the same time. This is technically possible, but if you were interested in trying this out, then we can essentially try it out. Okay, that would be quite interesting. Yeah. So again, very quickly, because I'm already a little bit longer than I intended to do. Is it possible to dark field in stereo with bottom and basically a dark field with a stereo microscope? Yeah, I don't have it here with me now. Something similar to dark field. What you do is you place the specimen on a mirror. Just a second. Look what I got here. It's a mirror. Just show you what you can try to do with a stereo microscope, light coming from the top, and if you put a mirror here, then the background becomes darker. Okay, so you can kind of imitate a little bit stereo dark field. Okay, these are again the because what happens is to get a dark background, you can also use this dark plastic disc. But look, if I do that, it's not dark enough. Okay, you see that it's still too reflective. So I know that there is this paint called Vanta Black, apparently, which is really absorbing. And that's also on my list, that I try to make a background for the stereo microscope, which is really black. But so far, sometimes I'm just using also a mirror, right? Yeah, and then you can, if you adjust it properly, then you get something similar that appears to be like dark field. Yeah, that's again the question about the small world photography contest. To win the contest is almost impossible, but we can get inspired to make our own pictures. We can learn about the techniques as well. Yeah, I also thought it's almost impossible because some of the specimens that they're using are so massively advanced. Yeah, it's really really cool. So what I'm gonna do is I think that's pretty much everything. And what I'm going to do now is I've checked back and Brunel. I've checked back and Brunel works fine from Canada. Good. Okay, so they do send internationally. Could I use bottom illumination stereo to look at a transparent echinus, then zoom in? Okay. Okay. Also a good point. You know what? We'll try it out. Yes, it is possible. Of course, I tried it, but it doesn't look quite as good. So basically, let's look at one of those slides using a stereo microscope. This is the top illumination. Okay, that's this big one from before. But the idea is to look at it with light from the bottom. See, that's always good. These comments are important because I wouldn't have gotten the idea to try it out. Okay, so this is basically now light coming from the top. Just a second, I will switch it off. I have to switch on the other light. Okay, and this is now light coming from the bottom. And this is now the maximum magnification that I can have with my microscope here, with a stereo microscope, and this is how it looks like. Again, looks different. And you see, it doesn't quite look as crisp and as clear because, of course, the resolution is an issue here. Right, because it's very far away. The objective, so the numerical aperture, yeah, is of course not quite as high as the one, yeah, from the compound microscope. And I'm going to now put it again under the compound microscope, simply that you see it as a comparison. So short answer: stereo microscopes work, but those transparent or semi-transparent slides are not the basically ideal specimens. And this is how it looks like, yeah, using my compound microscope. Yeah, and you see that there is indeed quite a big difference. Okay, you can even, of course, magnify much more as well. Yeah. So, folks, I think now I'm also really becoming a little bit tired talking all the time, but I really liked it. I would like to thank you, of course, for all of your comments and questions and everything. I would like to also thank you, of course, again for your support. Hope that you liked it as always. Considering the many comments, I think it was also interesting for you. Basically, recommendations what I should try are always welcome. So I don't know if I'm able to get some glycerin gelatin until next week, but at least that's also on my list now, because it has been also a request. And let's try to make a couple of slides using glycerin gelatin, even if it's a little bit more on the more difficult. On the more difficult side, okay? But that's basically also something where we're able to learn something new. And for me, it's always nice to do those microscopy videos and live streams, because I'm also now motivated to try new things. And of course, on my list, so to say, is how can I polish those spines to the degree that I'm also able to get a very thin cross section? I have still no idea. A little bit more research will have to be done here, but I'm going to leave it at that. I wish you all the best. If you have not liked and subscribed, I would like to invite you to do that as well, because this, of course, boosts the channel and the videos a little bit. YouTube likes it if there is some kind of activity going on as well. And Kai Alreno, mi volas danki vin por via bonega el sendo mi vere ĝuis ĝin. Mi volas danki vin pro tio kaj ĝis revido. These were a few words in Esperanto because it's another one of my hobbies that I have. Okay. Okay. All the best and see you next week again. Bye bye.